Electrical hazard. Group members.
IZZWANI, SYAFIQAH, AZZRIN, KHAIRINA, DAHLIA, IMAN, NUHA.
Electricity is a flow of negatively charged particles called electrons through electrically conductive material called conductors.
Substances that are neither conductors nor insulators can be called semiconductors. Electrical current passing through the human body causes a shock. The quantity and path of this current determines the level of damage to the body. The path of this flow of electrons is from a negative source to a positive point because opposite charges attract one another. When a surplus or deficiency of electrons on the surface of a material exists, static electricity is produced. The potential difference between 2 points in a circuit is measured by voltage. The higher the voltage, the more likely it is that electricity will flow between the negative and positive points. Most industrial and domestic use of electricity is supplied by alternating current. Because voltage cycles is alternating current and effective, the current for alternating current circuits is computed, which is slightly less than the peak current during a cycle.
The path of electrical current must make a complete loop for the current to flow. This loop includes the source of electrical power, a conductor to act as the path, a device to use the current called a load, and a path to the ground. The Earth maintains a relatively stable electrical charge and is a good conductor. The Earth is considered to have zero potential because of its massive size. Electrocution occurs when a person makes contact with a conductor carrying a current and simultaneously contacts the ground or another object that includes a conductive path to the ground. This person completes the circuit loop by providing a load for the circuit and thereby enables the current to pass through his or her body. People can be protected from this danger by insulating the conductors, insulating the people, or isolating the danger from the people. The National Electrical Code (NEC) is published by the National Fire Protection Association (NFPA). This code specifies industrial and domestic electrical safety precautions. The NEC categorizes industrial locations and gases relative to their degree of fire hazard and describes in detail the safety requirements for industrial and home wiring. Typical 110-volt circuit wiring has a hot wire carrying current, a neutral wire, and a ground wire. The neutral wire may be called a grounded conductor, with the ground wire being called a grounding conductor. Neutral wires usually have white insulation, hot wires have red or black insulation, and ground wires have green insulation or are bare. The hot wire carries an effective voltage of 110 volts with respect to the ground, whereas the neutral wire carries nearly zero voltage. If the hot wire makes contact with an unintended conductor, such as a metal equipment case, the current can bypass the load and go directly to the ground. With the load skipped, the ground wire is a low resistance path to the earth and carries the highest current possible for that circuit. A short circuit is a circuit in which the load has been removed or bypassed. The ground wire in a standard 3-wire circuit provides a direct path to the ground by passing the load. Short circuits can be another source of electrical hazard if a human is the conductor to the ground, thereby bypassing the load.
2. Sources of electrical hazard. Short circuits are one of many potential electrical hazards that can cause electric shock. Another hazard is water, which considerably decreases the resistance. When the current flow is reduced, the probability of electrical shock is also reduced. The major causes of electrical shock. First, contact with bare wire carrying current. Second, working with electrical equipment that lack UL level. Third, static electrical discharge. Fourth, using metal ladder to work on electrical equipment. 5. Lightning strike. Electrostatic hazard. Electrostatic hazard may cause minor shock. Shock from static electricity may result from a single discharge or multiple discharge of static. Sources of electrostatic discharge include the following: First, moving large sheet of plastic which may discharge spark. Second, the explosion of organic and metallic dust. Vehicle tire rolling across a road surface.
Next is combustible and explosive materials. High currents through contaminated liquids may cause the contaminants to expand rapidly and explode. Poor match between current or polarity and capacitors can cause an explosion. Overheating from high currents can also lead to short circuits, which in turn may generate fires or explosions. We go through to the lightning hazards. Lightning is static charge from clouds following the path of least resistance to the earth, involving very high voltage and current. Lightning may also damage airplanes from intra-cloud and cloud-to-cloud flashes. Lightning tends to strike the tallest object on the earth below the clouds. Improper wiring. Improper wiring permits equipment to operate normally but can result in hazardous conditions. One common mistake is to jump the ground wire to the natural wire. In a reverse polarity light bulb socket, the screw threads become conductors. If a short occurs in the equipment circuitry without proper grounding, anyone touching the equipment may be severely shocked.
Besides that, electric hazards can cause installation failure caused by the environment. Among them there are several ways in which equipment failure can cause electrical shocks. Electrical equipment designers attempt to create devices that are explosion-proof, dust ignition-proof, and spark-proof. Following are some of the more common types of equipment failure. Moreover, the NEC classifies hazardous locations for electrical equipment. There are three basic classes. Class 1 for flammable vapors and gases, Class 2 for combustible dust, and Class 3 for ignitable fibers.
Electrical hazard to human. The greatest danger to human suffering electrical shock result from current flow. The voltage determine whether a particular person naturally resistant to current flow will overcome. Some level of current frees a person to the conductor. The person cannot voluntarily release his or her grasp.
4. Detection of electrical hazards. A circuit tester is an inexpensive piece of test equipment with two wire leads kept by probes and connected to a small bulb. Most circuit testers test at least a 110 to 220 volt range. A continuity tester may be used to determine whether a conductor is properly grounded or has a break in the circuits. Infrared thermal imaging is another technique that can be used for detecting electrical hazards.
There are few ways to reduce electrical hazard. For example, applying electrical grounding system, separate equipment grounding, bonding, ground fault interrupter or GFI, and humidification.
OSHA's electrical standard. OSHA's standards relating to electricity are found in 29 CFR 1910, also known as Subpart S. They are extracted from the NEC. Subpart S is divided into design of electrical systems and safety-related work practices. The standards in each of these categories are as follows.
There are few electrical safety programs to be followed. Implementing comprehensive safety program, provide proper trainings to all workers in order to identify and control electrical hazards, ensure compliance with the National Electrical Safety Code, ensure PPE are available and worn by workers when needed, held scheduled and unscheduled safety inspections, conduct job site survey for construction site, provide testing or detecting equipment to workers who work directly with electrical energy.
8. Electrical hazard self-assessment. One of the best strategies for safety personnel is to ask for assistance of supervisors. To help prevent accidents and injuries from electrical hazard safety, personnel should consider developing checklists supervisors can use to undertake periodic self-assessment in their areas of responsibility. The checklist may include all the questions necessary and required to maintain a safe environment for the worker. First, are all electricians in your company up to date with the latest requirement of the NEC? Second, Does your company specify compliance with the NEC as part of its contracts for electrical work with outside personnel? Next, do all electrical installations located in the presence of hazardous dust or vapors meet the NEC requirements for hazardous locations? Next, are all electrical cords properly strung? Are all electrical cords free of fraying? Are rubber cords free of grease, oil, chemicals and other potentially damaging materials? Are all electric motors properly maintained and provided with the necessary level of overcurrent protection? Are all electrical switches properly marked to show their purpose? Are all connections clean and tightly made? And the last, are all metallic cables and conduit systems properly grounded?
Prevention of arc flash injuries. An arc flash is an electrical short circuit that travels through conductors. The uncontrolled energy released by an arc flash can produce high level of heat and pressure. The best way to prevent is to de-energize the electrical equipment.
Some maintenance and service functions such as troubleshooting require that the equipment being worked on be energized. When this is the case, it is important to consult the NFPA's Handbook for Electrical Safety in the Workplace as updated in 2009 and proceed as follows.
Next, maintenance requirements of NFPA 70E. The 2009 update of NFPA 70E contains several requirements relating to maintenance. These requirements are as follows. For 205.3 general maintenance requirements, overcurrent protective devices shall be maintained in accordance with the manufacturer's instructions or with industry consensus standards. For 210.5 protective devices shall be maintained to adequately withstand or interrupt available fault currents. For 225.1 fuses shall be maintained free of breaks or crack in fuse cases, ferrules and insulators. 225.2 molded case circuit breakers. Molded case circuit breakers shall be maintained free of crack in the cases and free of crack or broken operating handles. And 225.3 circuit breaker testing. Circuit breakers that interrupt faults approaching their interrupting ratings shall be inspected and tested in accordance with the manufacturer.
OSHA's training requirements for all workers are contained in 29 CFR 1910. The training requirements for workers who face the risk of electric shock that is not reduced to a safe level are clarified in OSHA CFR 1910-332. The standards requirements apply to the following classifications of workers.